Chris Chinnock here, CES 2026. It's in the Aledia suite here in the Venetian. So Felix, you're going to take us through this. Please update us.
Thank you, Chris. Everything we show here is made out of our 200 millimeter semiconductor line, okay, gallium-nitride. And let's talk about the first, let's say the first technology, which is called native. Why? Because natively we produce green, the blue, and the red.
Yes.
Okay, and here are the first prototype out of our line, which is fully equipped now since October, November. Okay, and everything we do now will be out of the 8-inch silicon fab in Champagny, Grenoble, France. Okay.
Right now, you source the base wafer.
Today we source it, okay, but we just entered into the room 193 nanometer photolithography, and we're going to do it by July, the first, let's say, base wafer on which we're going to grow, let's say, our nanowires, which are in between 100 nanometer to 400 nanometer.
Okay, fantastic.
So today we've demonstrated, let's say, the three colors, so what we call monochrome, okay, on a pitch of 2.5 micrometer, okay, and therefore what we demonstrate here is, let's say, an Aledia logo, okay, which is about 2 millimeter per 1 millimeter, okay, which has about 14,000 pixels and 900,000 nanowires. Okay.
Wow. Okay. Now, it's just to back up to set the stage here.
Yes.
So when you do nanowires, the color is based on the size of the nanowire.
Right.
So it's all one base growth material. You can and theoretically, you can grow red, green, and blue on one wafer by varying the size of those growth elements. Correct?
Exactly, Chris. Yeah, and you can see here the structure, okay, of a monolithic RGB. So we grow in once and one epi growth in a wafer, the three colors at the same time, right? And you see here the structure, which is very well defined.
Yes.
And after that we get, let's say, natively the three colors with a pitch today of 2.5, but ultimately what we've calculated, let's say, is that the 2.0, so the 2 micrometer subpixel pitch is the best suited pixel pitch for our technology.
Okay. And the reason to go to monochrome to start is just because it's easier than doing full color?
Yes, right. We are working with some customers already with, in order to define, let's say, the roadmap, okay?
Okay.
The blue and the green has been demonstrated, and we are now fully focusing our effort on the red.
Okay.
Because once we have a red which is, let's say, fitting the requirements of our customers, we will apply the same recipe on RGB, and then we'll build the green, and the blue will come for free, actually, into bracket. And this is why we start with monochrome. Also, because some customers are asking for monochrome.
Sure. There's a market for that too.
There is a market for that too, for the green also,
for sure.
Especially. And then it's a path towards having an RGB, let's say, by 27 with the performance that customers are waiting for.
Okay. Okay, so tell me more about the roadmap now with the new fab and everything.
Yes, so we've developed some test vehicles on the line in order to, let's say, bring the technology and to improve, let's say, the performance of the technology, okay, to the levels that we committed to some customers. And therefore, by mid of this year, we're going to get the first prototype of the monolithic RGB.
Okay.
and of course, in the meantime, let's say the three colors will be evolving by their own towards, let's say, improving the performance.
Yes.
But the first, let's say, the first RGB, monolithic RGB will be demonstrated on the 8-inch wafer fab in June. Okay, so end of the second quarter.
Okay.
And then, of course, both will evolve until 27 for let's say a mass production of 28. Okay, and depending on customer request, of course, we will be the hybrid. We'll do the hybrid bonding in house. Okay, whether we do it with a CMOS driver of a customer, of an end customer, or an off-the-shelf that we're gonna supply to third tier or to second tier customers, and this is our plan.
All right. What are the other challenges you're working on?
So the challenge is, of course, as I said, I mean, we're working right now with on the red. I mean, it's the first, let's say, the first samples has been, let's say, have been out of the line. You see it? Yeah. So these are the first prototype out of our line. Okay. Okay. So this is on let's say on the native technology, okay, and you have all the details here, by the way, okay. You can capture, let's say, the details here. Yeah, yeah. That we anyway have released in the press those days.
Okay. Do you talk about luminance levels and efficiency?
Yeah, today the efficiency, I mean, you know, it depends on, let's say, in which, let's say, cone we want to, let's say, to have the EQE. Today we are measuring in a cone of plus or minus 12 degrees. We are getting very few, let's say, very few percent, even less than 1%, okay? But again, this is just the beginning of the process.
Right, okay, okay.
So we give you more, let's say, hints, let's say, hopefully in 6 months from now.
Okay. All right. What else are you talking about here and showing?
We are showing, let's say, briefly here. We can show you. I don't know if you see, but this is let's say a technology which is fitting for a direct view. Okay, it's a microLED which is 3.5 micrometer. 5 micrometer pitch, 3.5 as a size, and we are supplying to customer today a 15 by 30 micrometer, 6 volt and also 9 volt. Okay, by end of the first quarter. So high voltage, which saves let's say about 30% power on the at the display side,
at the system level.
At the system level, yes, that's right.
Yeah. Okay.
So this is already sampled to all the big 5.
Yeah. Well, this is good because this is the mainstream product right now.
Yeah, exactly. It's fully in production. Okay, and they are now testing, let's say, the high voltage feature.
Okay.
Okay, which nobody has the 9 volt, for instance. Okay, nobody can do it.
Yeah,
and we are the only one who can do it easily because it's nanowires, pillars that we put in series.
Really?
So we can do it very easily by a semiconductor layer. Okay.
Okay.
Metal fix.
And now, can CMOS drive 9 volts? What do you have to go to for a driver?
This is not our part, actually. Okay, the driver is on the
customer side.
Yeah. Customer side, yes.
Okay, but it is. But they do have. I presume I can do it. Can I do it in CMOS? I don't know.
Yeah, but today we are only supplying, let's say, the LED.
Yeah,
okay?
Yeah.
And all the rest, let's say, the driving is made by.
You're not worried about that.
Exactly.
Not your problem.
Exactly. So thank you very much, Chris. Okay.
Thank you
very much.
Appreciate it.
Thank you.